Hey guys, it's Mr. again. Today we're going to look at graphing inequalities with two variables. Don't forget, as you're watching the video, you can always pause, go back and look at something again, take your time with it, take notes if you think that's helpful. Alright, so we have graphed inequalities with one variable. We use a number line. Now we're going to look at graphing inequalities with two variables. So we're going to look at something like this. Y is less than 2x minus 1. Okay, if you notice, it looks very similar to equations that we've graphed, linear equations. It looks like it's in slope-intercept form. The only difference is a less than symbol instead of an equals. Alright, let's take a look at one. Let's do y is greater than or equal to 2x plus 2. Alright, so when I look at this inequality, it does look like it's set up like a linear equation. It's a linear inequality. It does look like it's set up in slope-intercept form. This would be our y-intercept at positive 2. So I'm going to put a little point there, positive 2. This is going to be our slope, 2. And we know that that's the same as 2 over 1. That way we have a rise and a run. So I'm going to rise up 2, run 1, put a point. I'm going to draw my line through those points. Put arrows on the end of my line. All right, now the difference is going to be, this says that y is greater than or equal to. When it's just equal to, it's the line. But since it can be greater than or equal to, then it's going to be everything above the line, everything in this area. So I'm going to have to shade all this in. So everything above that line, I'm shading in. I don't want to shade onto my inequality there, but roughly that's what it's going to look like. I'm just going to shade everything above the line. So if it's greater than, above the line. If it would have been less than, it would have been over here below the line. All right, now, the biggest mistake people make in the beginning is shading it on the wrong side. So there's a way to test that. You come over into this shaded area and pick a point. So I'm going to pick a point right there. That point is at negative 3, comma, positive 3. All right, I'm going to take that point and I'm going to plug it into our inequality. And then I'm going to check to see if it is true. If it becomes a true statement, then that means I shaded on the correct side. So my y value is 3. So I'm going to put 3 in for y. Greater than or equal to 2 times my x value is negative 3 plus 2. 2 times negative 3 is negative 6. Negative 6 plus 2, negative 4. And now, is my statement true? Is 3 greater than or equal to negative 4? Yes. So then that point is in the correct place, and I shaded in the correct area. All right, let's try another one. Let's do y is less than negative 3x plus 4. Alright, so my y-intercept, 2, 3, 4, put a point. My slope, which is negative 3 over 1. So I go down 3, 1 to the right. Alright, now, before I draw my line, this only says less than. There's no equal to part. The equal to part is the line. Since there's no equal to part, I really can't draw a solid line. So I do need something to go through those points. So what I do is I draw a dashed line. The dashed line represents where I want to go through my 2 points, but since it's not a solid line, it shows that I'm not actually including that line. Kind of like when we graphed on a number line and we use like an open circle when we wanted to start the number but not include it, and we used a point when we wanted to include it. Same thing here. Dashed line when we don't want to include it, solid line when we do. Alright, now it's less than. Less than would be below the line. So below the line is over here. So I'm going to shade over here below the line. And there we go. That's our graph. Once again, like I did before, if I want to check, I can pick a point somewhere in the shaded region, plug it in, see if it works out. Alright, let's try another one. Let's do y is greater than negative 1/4 x. Well, let's do that. Y is greater than negative 1/4 x. So my y-intercept is 0. That's my origin. My slope, negative 1/4. So I can either put negative 1/4 or I can do positive 1/4. I'm going to choose this. So negative 1 means down 1. Positive 4, 4 to the right. 2, 3, 4. Put a point. It's greater than without an equal to part. So that means I'm going to do my dashed line. Now, even though it's a dashed line, it still needs arrows on it, don't forget. And then greater than means I'm shading above. So I'm going to shade up here. And there you go. Y is greater than negative 1/4 x. Alright, now we're going to take a look at a couple that are a little bit different. Y is less than or equal to, let's say, negative 3. Alright, we know from graphing linear equations that when you would have y equals a number, the slope is 0. That's why you don't see an x in this. And you know it's going to end up being a horizontal line. So I know that it's going to be a horizontal line going through negative 3 over here on the y-axis. That's our y-intercept. There is an equal to part, so I am going to draw a solid line. Put my arrows on there. All right, now it's less than or equal to. So less than would be below. So it's real easy with a horizontal line. Below is down here. Above would have been up here in this area. But less than is below. Okay, on the diagonal lines, sometimes it's hard to see, what the below part is, especially when the line has a real steep slope. But I think a horizontal line is pretty clear. You're either below it or you're above it. Less than below, greater than above. But then we have one like this. X, let's say, is greater than 2. All right, so we know this inequality looks a little different because when it was an equation, it looked different. It wasn't in that y equals mx plus b form, or it didn't look like it was. And we know that this turns out to be a vertical line. So we know it's going to be a vertical line. It's going to go through 2 on the x-axis. There's no equal to part, so I'm going to need a dashed line for this one. And now here's where the tricky part comes in. Greater than. Well, it's a vertical line, so I can't shade above it, and I can't shade below it. So now you have to think, well, logically, if I was looking at a vertical line, what would be greater, to the right or to the left? Well, if you were thinking about the horizontal axis, the x-axis, like think of it as a number line. The numbers are getting bigger as they're going this way in the positive direction. They're getting smaller as they're going this way in the negative direction. So if I want greater than, I must be shading to the right. So greater than would be a shade to the right. Less than would be a shade to the left. Okay, that's a little bit different because there's not a above or below. But I think it makes good sense. Greater than to the right where the numbers get bigger on the x-axis. And if it was less than, it would have been to the left. Alright, that's essentially it, guys. Graphing inequalities, very similar to graphing equations. Make sure that your equation is in slope-intercept form. Once it's in slope-intercept form, graph just like we've been graphing. Find that y-intercept. Use your slope, rise over run. If there's an equal to part, you're doing a solid line. If there's not an equal to part, a dashed line. If it's a greater than, you're shading above. Less than, shading below. Alright, good luck.